Hello everyone. Our topic is U.S. car accident severity analysis.
The traffic hazard has been increased during the decades, and the car accidents take place frequently, which causes a huge loss of life and property. In the United States, around 35,000 people die every year in the car accident. The increased number of accidents requires more precise, fast way to estimate the real loss of the accident. In this case, predicting accident severity would be a possible solution to help decide the true loss of the accident. In the past few years, researchers applied decision tree, random forest, naive Bayes, k-nearest neighbor, and support vector machine models to the road environment features. The result shows that the more advanced the model, the better the accuracy. In our study, we will use the US accident data from cargo to predict the accident severity based on the road environment with both traditional and more advanced table. We successfully obtained a model with around 85% accuracy using objective variables to predict the severity level of the accident. The increasing number of accidents raises the concern of insurance claims fraud. There are two types of claims fraud. The first is illegitimate claim. The second is exaggerating the loss amount. People used to detect fraud based on the auditing patterns, which basically is what the claimer said. However, the accuracy of this method depends on the claimer's honesty. In order to overcome this limitation, our group focused on the objective surroundings where the accident happened. As a classification problem, we use the objective factor to predict accident severity level to help insurance companies to avoid claim build-up and reduce their loss.
To analyze the data, we first clean the dirty dataset. The original dataset contains more than 3 million data, and we first randomly sample 200,000 data for easier computation. We drop the columns with too many missing values or contain meaningless information. Then we sort the data by time and location to make sure the data next to each other are related, so that we can fill them out by the previous values. We categorize some features based on their properties. For example, we change continuous temperature, humidity, and visibility to categorize intervals, and categorize the weather type to extreme, clear, and others. Then we make all the categorical variables dummy variables, and then normalize them. To gain a general view of the data and obtain better result, we perform the following procedures. We use random forest to check the feature importance, and it shows that there's no particular feature that has obviously huge impact on severity. We also tried PCA to see if it could help with the performance. The models we selected were decision tree, random forest, k-nearest neighbors, logist regression, and two popular train-based ensemble methods, XGBoost and LightGBM. After the basic training is done, the models with the best performance are selected to perform research and cross-validation to better tuning the model and get more accurate evaluation. We realize the dataset is too broad and contains too much diverse information, since it includes the accidents happen all over US, which might be a problem for our study. For instance, the traffic pattern in Worcester must be different within New York. Therefore, we extracted the data of New York City to perform the same analysis. Also, due to the property of XGBoost and LightGBM that they separate and categorize the data very well, we tried training some models for New York City's accidents with a rougher data cleaning process. This time, we only categorized weather type and calculated the duration of the accident in minutes. We noticed that the data is imbalanced according to the severity. Severity 1 only has a few records, and 3 has too many. So we tried to resample the data to get more balanced dataset as well.
The picture shows the number of accidents for severity level 4 in each state. More and more accidents happened over years from 2016 to 2019. In terms of other severity level, there also appears the same pattern. In this picture, The central is the line plot, which we can see the most accidents happen around 8 a.m. and 5 p.m. It might be because it's a rush hour for commuting. People are more likely to have accidents. We guess people may get late to work and hurry on their way. Among all the accidents, there are only 0.02% of the accidents have bumper around the road, and 4.39% of them have junction nearby. Around 10% accidents happened near the crossroad, and 1/5 accidents happened with traffic signal aside. Other location attributes are generally follow the same pattern and not contribute a lot to the total number of accidents. This picture maps the top 100 accident points that are reported frequently. The top 3 points are located in Dallas, Miami, and Green Valley, with cases of 627 and 585 respectively. 76% of them happened at daytime, which means the limited visibility might not be the only reason that will cause an accident. The bar chart shows the influence of the top 4 points. Among the 4, I-95 route affected the traffic condition most seriously, which shows 253 miles of the road are affected in total of past 4 years.
So we can draw a conclusion in our first result table without PCA as future selection. First, accuracies of XG boost and night GBM are 0.81 and 0.84, so they have best performance among all the algorithms. And second, compare with resampling and without resampling method we use. The results show that they do not, improve the accuracy, which means our resampling method does not suit this dataset. And third, when we focus on particular area, New York City, the models perform better results. And finally, the detailed data processing we complete did not have very satisfying performance compared to the roof processing. And we can draw same conclusion in our second result table with PCA as future selection. And what's more, we think PCA is not required in this case. Finally, there are some suggestions for future studies. First, the data processing and resampling method can be further implemented and tested in the future. And second, parameter tuning can be improved by adding more options, since we did not try many due to the limitation of computational power. And third, more algorithms, especially the algorithms that are not tree-based, such as deep learning, can be tried in the future studies. And first, different area with higher amount of data than New York does, such as California, can be analyzed and studied. That's all. Thank you.